Okay, let's talk about speaker processing. The first thing we're going to do is we're going to clean up the file that we've been working on. Let's delete the level control block, and let's go back to our auto mixer, right-clicking and hit Edit Block Parameters, and let's take off the direct outputs and just go back to a single mixed output. So this will make it a lot simpler. Also, we're running out of room to our right, so I'm going to use a split pass-through. I'm going to take my output block and move it down here. And then I'm going to use this thing called a split pass-through input. And up here in the menu, the last menu that looks like a compass, you'll see the split pass-through input. I'll drop it down on the screen. And we have the option of making it an audio or a logic and how many channels we want. In this case, we only need one channel and it's an audio path. And what a split pass-through input and output is, a split pass-through link, is it allows us to jump from one spot on the screen to another spot on the screen without any wires in between. Just an easy way to do some cleanup wiring. So we're going to bring the link in here, and I'm going to connect the mixed output of the auto mixer to the link in, and then I'm going to take the link out, and I'm just going to come down here and start a second row. So it's easier for me to work left to right and then jump down, work left to right, jump down, work left to right, rather than scrolling back and forth to the left and the right and up and down and all over. So let's also rename this. So if we click here and hit enter, we can rename this mix, and I will delete the APT link in, hit enter, and it'll ask us, do you want to update all the associated links with this text? And I'll hit enter again, and you'll notice that the receive block is also changed to mix. So now we have the signal from the mixer just on a new place on the screen. So the first thing that I typically do in a signal path for speaker processing is I will use a high pass filter or a low pass filter as appropriate, or a crossover as appropriate. But in this case I'm going to use just a high pass filter, and we're going to consider that our speaker are some ceiling speakers and they can only handle down to a certain frequency. So we are going to connect up our high pass frequency, and we're going to open it up. And we're going to say that our ceiling speakers can only handle down to, let's say, 60 Hertz. And we're going to let that roll off nice and slow, maybe 12 dB. Let's go to 24 dB per octave. So it will just drop off really rapidly there at 60 Hertz. And the next thing I would do is I would include a parametric equalizer. Now I like parametric equalizers instead of graphic equalizers. One, they use a lot less digital signal processing power, and secondly, we can get a cleaner, more accurate equalization, because a graphic equalizer is really just a bunch of parametric equalizers with two of the functions disabled for us, and we only have gain. Let's grab the parametric equalizer, and typically on a speaker, if it's a good speaker, 5-band is more than enough in the room. If it's a really bad room or a challenging room or a cheaper speaker, then maybe a 7-band would be appropriate. So I'll grab a 5-band, we'll bring it down here, and we'll put it into position. And then we will come, and the next thing I usually do is I put a compressor limiter. And the purpose of this compressor limiter is really more just a brick wall limiter, speaker protector, if you will. So what I typically do is I go and set it at about 10-to-1 ratio, and that means for every 10 decibels the input rises above the threshold, the output will only go up 1 decibel. So even if we hit 20 dB above unity, we are going to only go up to 2 dB above unity on the output. But typically I want it to just stay out of the way until it just gets really loud in the place. So I'll start with it at about +8. Basically a good starting point. On the parametric equalizer, we'll come back to it, but we can look at and tune the room, and we'll talk about room tuning in another video. Then we connect this to our output block. And I'm going to make a long line here and drag the output block back to us. And the other very important thing that we need to do is we need to add a meter for the output. We have meters on the input and we have meters on the output, and that allows us to see at least the beginning and the end. In this case I only need a 1-channel meter, and so I'll slide that here. Now we can't actually meter the output block, so we meter what is being sent to the output block. So right here, off of this comp limiter, we will Y the signal. Because we are in the digital world, we can Y a signal as many times as we want. Of course, we can only mix with a mixer block, such as the auto mixer or a standard mixer or matrix mixer. But in this case, we just need to Y the signal to the meter, and we need to send it to the output block. So as you can see, on our meter, we'll be able to read and see what our signal level is by the time it's gone through all of our processing. And once again, another great troubleshooting. So I will typically minimize that and put that up at the top of the screen. Additional items that may go into a speaker path may include something like a delay or a feedback filter, but in this case we'll keep it very simple. A high-pass filter to get rid of the low frequencies that the speaker can't handle, a comp limiter to set a top end that the signal can reach to protect the speaker, and then Parametric Equalizer to match our speaker system and our room together. And then we'll take that into our output block.